Hello, NEET aspirants, ready to dive into the world of wave mechanics and conquer those calculus-based problems? In this video, we are solving some challenging questions to boost your understanding. Problem 1. The equation for a wave is given by y into bracket x comma t bracket close is equal to a sine of kx minus omega t. In this equation, y into bracket x comma t bracket close represents the displacement of a particles along y-axis. Depending on both the particle's position on the x-axis x and time t, the term kx indicates the spatial component of the wave, representing the energy disturbance propagating along the positive x-axis. To find the velocity of a particle along y-axis at any given position x and time t, we take the derivative of y into bracket x comma t bracket close with respect to time t. When differentiating sine of kx minus omega t with respect to time, we treat kx as a constant because we are focusing on the rate of change of y with respect to time at a specific point in space x. The result is minus a omega cos of kx minus omega t, where omega is the angular frequency. Therefore, the correct expression for the velocity at time t is v is equal to minus a omega cos of kx minus omega t. Option C is correct. Problem 2. Wave equation is y is equal to 0.2 sine of 12 pi t plus 10 pi x. Take the derivative of the given wave equation with respect to time t to find the velocity of the particle. We get u is equal to 0.2 into 12 pi cos of 12 pi t plus 10 pi x. On simplification, we get u is equal to 2.4 pi cos of 12 pi t plus 10 pi x. We have to use the trigonometry to change the cos function since both have different trigonometric functions. We have to use the trigonometry to change the cos function in velocity equation to sine function. Then only we can subtract the phase. We will use the trigonometric identity sine of theta plus 3 pi by 2 equal to cos of theta. Our equation for the velocity is u is equal to 2.4 pi cos of 12 pi t plus 10 pi x. We will change the function cos to sine and add 3 pi by 2 in its phase. By doing so, we are not changing the value of u. So, we get the new equation for the velocity as u is equal to 2.4 pi sine of 12 pi t plus 10 pi x plus 3 pi by 2. Equation for the displacement is y is equal to 0.2 sine of 12 pi t plus 10 pi x. Phase difference is equal to phase of velocity equation minus phase of displacement equation. Therefore, into bracket 12 pi t plus 10 pi x plus 3 pi by 2 bracket close minus 12 pi t plus 10 pi x equals to 3 pi by 2. So, phase difference is 3 pi by 2. Option D is correct. Problem 3. Graph shows the wave is propagating along positive x-axis. Wave equation for the wave moving along a positive x-axis is given by y is equal to a sine kx minus omega t. By taking the derivative of y with respect to t, we get u is equal to a omega cos kx minus omega t. Here also, we have to take kx as constant as particle is oscillating at a fixed point on x-axis. Note, derivative of cos function is minus sign. By taking the derivative of u with respect to t, we get the acceleration a equal to minus a omega square sine kx minus omega t. By substituting k is equal to 2 pi upon lambda and omega is equal to 2 pi by t, we get the equation for acceleration as a equal to minus a omega square sine of 2 pi upon lambda into x minus 2 pi upon capital T into small t. Given that t is equal to 2 seconds, lambda is equal to 4 meters, and x is equal to 2 meters, and form the graph, amplitude A is equal to 1 meter, periodic time t is equal to 8 seconds. Substituting the values in the equation for acceleration, we get A is equal to minus 1 into omega square sine of 2 pi by 4 into 2 minus 2 pi by 8 into 2. Therefore, A is equal to minus omega square sine of pi minus pi by 2. On simplifying it, we get A is equal to minus omega square sine of pi by 2. As sine of pi by 2 is equal to 1, we get A is equal to minus omega square. On substituting omega is equal to 2 pi by t, we get A is equal to minus into bracket 2 pi by t, bracket close raised to 2. By substituting t is equal to 8 seconds and simplifying further, we get A is equal to minus pi square upon 16 meter per second square. Option C is correct. Problem 4. Wave equation for particle is y is equal to y naught sine of 2 pi upon lambda into bracket vt minus x bracket close. In the equation, v is the velocity of wave, not the velocity of particle. Taking the derivative of y with respect to t, we will get the velocity of a particle as u is equal to y naught into 2 pi v upon lambda into cos of 2 pi upon lambda into bracket vt minus x bracket close. Here also, we treat x as constant as explained before. To find the maximum particle velocity, we set cos of 2 pi upon lambda into bracket vt minus x bracket close is equal to 1. This simplifies our equation to u max is equal to y0 into 2 pi v upon lambda. Maximum velocity of particle is equal to 2 times wave velocity. On substituting the value of maximum particle velocity and wave velocity, we get y naught 2 pi v upon lambda is equal to 2v. On simplifying, we get lambda is equal to pi into y naught. Option D is correct. Fantastic job, NEET warriors. If you enjoyed riding the waves of calculus and wave mechanics with us, don't forget to like, share and subscribe. Stay tuned for more problem-solving adventures. Until next time, keep conquering those waves of knowledge.